So in the first slide, I'll introduce my project title, Apply Data Mining of Portals and Public Bus Stops in Kansas City, a geospatial and clustering approach. I'll briefly explain that the study focuses on using data mining techniques to analyze how portal occurrences impact public bus stops accessibility. I will also mention that this project was developed for Park University's Applied Data Mining course to address real-world infrastructure issues using big data analysis. So to the introduction, I will discuss why this topic is important. Potholes are a consistent infrastructure challenge in Kansas City, often causing disruptions in road safety and public transportation reliability. I would also explain how poor road conditions directly affect bus stop accessibility, especially in high traffic areas. Let's move on to the aim of this work. In this session, I'll summarize the main objectives of the project. The key goal was to examine the spatial relationship between portals and public bus stops to determine where accessibility is most affected. I'll also highlight that the project aims to provide recommendations for better maintenance, prioritization, and demonstrate how data mining can enhance city infrastructure management. Now let's move to the data description. So with the data description, the first data set, the Kansas City portal tracker, includes over 5,000 records of reported portals with details like resolution status, open and close dates, and geographic coordinates. The second data set, that is the Kansas City bus stop data set, contains over 1,000 records with bus stop IDs, names, coordinates. I would also mention how I integrated these datasets using geospatial mapping, applying a 100-meter proximity threshold to link portals with nearby bus stops. The integration allowed me to assess where portals have the greatest impact on public accessibility. Now let's move to my literature review. In this slide, I'll summarize the theoretical foundation of my study. I will mention that previous research by Han et al. 2022 shows how data mining can reveal patterns in complex infrastructure systems. Below are other reviews I got through doing this work. Now let's quickly move to the results. So this basically is the explanatory one. The slide presents the initial mapping of portals across Kansas City. I will explain that the explanatory analysis reviewed a heavy concentration of portals in downtown Kansas City with fewer issues in the um, suburban areas. Now let's look at the clustering analysis. This slide delves into the clustering results using k-means algorithm. Let me explain three main clusters that were identified. Let's move back. So here, 40% of bus stops affected, and then 30% portals resolution rates. Cluster 1, that is the midtown, 20% affected, 45% resolution rate. And then, as you can see, stated with the suburb also 8% of stops affected and 55% of resolution rate. Now, with the predictive modeling and scalability, this was performed using Python, which handled the data set efficiently. I will note that if the analysis were explained to include multi-year data, weather effects, and traffic flow, distributed computing tools such as Apache Spark and Hadoop MapReduce would be necessary. I will emphasize that these tools can process larger data sets in parallel, allowing for real-time geospatial analysis and scalable infrastructure monitoring. So with my conclusion, With my conclusion, I'll summarize the key takeaways. The study found that downtown Kansas City faces the greatest accessibility challenges due to high pothole density, low resolution rates, and then also I'll discuss how this highlights the need for city planners to prioritize maintenance in high transit areas. This my references. Thank you very much for spending time with me. My name is George Kumi, and it was nice working with you guys. Thank you.